Hello learners, I'm teacher Ivan from Wuna Educational Services. We are still looking at how to solve simultaneous equations with three unknowns. In our first video, we looked at how we use elimination method. In today's video, we are looking at using reduction to row echelon form. I call upon for your attention and the observation because it's a bit tricky and lengthy. Let us start. We are considering equations to be solved. We have three equations: equation 1, equation 2, and equation 3. In all of these three equations, we have the same variables, that is x, y, and z, having different coefficients. The first step is to write the equations in the matrix form by considering their coefficients and the variables and their respective answers. So we form equations in matrix form just like the way you see here. After writing the equations in matrix form, we formulate the augmented matrix. How does it look? In augmented matrix is where we bring the equivalents or the answers to the equations in the same matrix as the coefficients. We are bringing the answers A, B, C in the same matrix of the coefficients to have our augmented matrix. After formulating the augmented matrix, we move to our third step. That will be now eliminating elements below the major diagonal in the coefficient matrix, which result into a triangular matrix. This is what we mean. We are considering the elements in the major diagonal of the coefficient matrix. Leave alone the answers or the equivalents, but we are considering those elements in the coefficient matrix. Those elements in the major diagonal, those that are below the dotted line, that is to say A2, A3, and B3, those are to be reduced to 0. That is to say, elements to be eliminated are A2, A3, and B3. So, how are we eliminating these elements? Element A2 is to be eliminated by subtracting A2 over A1 times the first row of the second row. Subtracting A2 over A1 times the first row. This is our first row. So we multiply this first row by A2 over A1. And after multiplying the first row by A2 over A1, we subtract our result from the second row. Hope we are together. That is how we are eliminating A2. Then to eliminate A3, we shall subtract A3 over A1, that is A3 over A1 times the first row from the third row. That is to say, we shall get A3 over A1 times the first row, and we subtract what we shall get from the third row. That is how we are eliminating A3. Then A2 is eliminated by getting A2 over A1 times the first row. And what we shall get will be subtracted from the second row. Hope now you understand the logic of how we eliminate A2 and A3. A2 is eliminated once again by dividing A2 by A1 times those elements in the first row. What we shall get after multiplying is what we shall subtract from the second row. Then eliminating A3 is by getting A3 divided by A1. What we get, we multiply by the first row, those elements in the first row, and take away from the third row, as we shall see in our examples. Then that is how we shall eliminate A2 and A3. So this is, first of all, we shall name the rows. This is row 1, row 2, and row 3. So now we are going to subtract and get the new matrix. This is how we are going to do it. Now, eliminating using the formula, the first row will come as it is, untampered with. But in the second row, we are getting the second row will be transformed into the second row minus A2 over A1 times the first row. So after dividing A2 by A1 and multiply with elements in the first row, what we get, we subtract it from those elements in the second row in their corresponding positions. As we shall see in examples, the same applies to A3. We shall say row 3 minus A3 over A1 times row 1. Meaning, if I'm to eliminate this to 0, I'll get this over that times this, and subtract it from that to get a 0 here, as we shall see in our examples. So that is how we are getting 0 here and there. Then meaning we shall be remaining with B3. So that will give us a new matrix where A2 is now eliminated and A3 is eliminated. Hope we are together.